Hello guys, welcome back to my channel. So today we're going to continue again with the OSPF. We added additional areas. Okay, we added the OSPF area 1, area 2, RIP area, and the ERGRP 50. So what we're going to do right now, we're going to start configuring the dynamic routing into the additional areas. We're going to start with area 1. Area 1, if we go into router 2, router 3, and switch to run section router. Okay, so on router 1, we see that we advertise everything in area 0. Okay, now we have to advertise the slowback 1 in area 1. And also the interface facing router 7 in area 1. Okay, so all we need to do on router 3 is configure terminal router OSPF. We're going to maintain the same the OSPF process is locally significant, so if we can still use the same process ID. Okay, it doesn't make any difference. So yeah, so it's going to be process ID 1, and then we say router. Network. So first network we want to put in area 1 is going to be 103.0.4.0. Okay, and we can say the subnet mask for this one is 0.0.0.255. Okay, we say it's area 1. Okay, we'll do the same thing for the interface facing router 7. So it's network 197.168.37.0. Area 1. Okay, so after that we go out of there, and we could actually just issue that command again to show run session router. Okay, so we have some interfaces that are running in router 1, okay, and others are running in router 0. Sorry, interfaces running in area 0, and then some other interfaces running in area 1 as we configured. So we're going to do the same thing on router 7. That in router 7, all the interfaces are going to be in OSPF. Okay. Router 7. Okay. On router 7, what do we have? See, if I do show IP interface brief, see all the interfaces that are there. So we're going to say configure terminal router ID. Okay. So, OSPF 1 router ID is 0.0.0.7. Okay. Now let's advertise the network. What networks we're going to advertise now? We're going to advertise 7.0.0.0. Okay, 0.255.255.255, and this is going to be in area 1. Okay, so we're going to also advertise network 192.168.37.0. 0.0.0.255. Okay, call it in area 1. We'll do the same thing for the other network, which is 79, network 79. Okay, area 1. So I'm gonna basically go out of there. Then I'm gonna do show run. Yeah, show run. router. Okay. Show run section router. Okay. All right. So we have all our networks advertised in area 1. Okay. And if that's the case, from router 7, we should be able to ping the loopback interface of router 3, which is in area 1. Okay. If the way we set it up, if it's all right, we should be able to ping. But then let's check. Do show IP OSPF neighbor. See if there's a neighbor relationship. Okay, there's a neighbor. That's good. Which means if I do show IP OSPF, not IP route OSPF. Okay, I'm going to include 1.3. Okay, so we have that network there. So if I can ping it 103.0.4.3. okay, we're sourcing from loopback 0. That ping should work. Okay, so that's a good sign, which means our area 1 is working properly. But the thing is that, of course, we cannot be able to let's see what route we're seeing from coming from area 0. Okay, if I do show IP route OSPF. Okay, all right, so we're seeing routes coming from OSPF. Okay, and you're going to see those routes are called inter-area. Okay, IA. So which means our route 7 is able to see route now coming from area 0. Okay, because we haven't enabled area 2 yet, so it's able to see the 5 network. Okay, 5 network of this out of 5 we put it in area 0. Okay, but the 105 we cannot see it here. We shouldn't be able to see because we put the 105.0.4 network in area 2, so we shouldn't be able to see that one here, right? So in the same way, let me advertise. Let me put R9 into OSPF area 1. Okay, the loopback interface of R9 plus the interface. Okay, let's go to R9. Just save this one. Yeah, like this. Sometimes I forget to save. All right, so let's go to R9. So if we go to R9, we show IP interface brief. Okay. So on R9, what we're going to do is this interface 7.9, we're going to put in OSPF. So this loopback 0, we're going to put in OSPF area 1. Okay, so let's do it right away. Configure terminal router OSPF process 1. Okay, and we say router ID. Okay, router ID 0.0.9. Okay, then we broadcast the network that we're going to want to inject into OSPF will be network 9.0.0.0 0.255, and then it's going to be area 1. Okay, and then we'll do the same thing for network 192.168.79.0, and it's going to be area 1. Okay, so let me save this. If everything is done right, I should be from router 9. I should be able to ping the loopback interface of router 3 that is advertised into OSPF area 1. Okay, so let's do it. Do that and do ping. Before then, let's see. Show IP OSPF neighbors. neighbor relationship. Okay, this neighbor relationship with router 7. Let me ping. Let me first of all ping the loopback interface of router 7. Okay, source from our loopback 0. Okay, that ping is working. If I do the same ping to the loopback interface of router 3 that's injected into that area, so it's going to be 103.0.4.3. okay, sourcing from loopback 0. Okay, that one is working as well. But if I ping 3.3.3.3, I'm trying to ping the loopback interface of router 3 that is in area 0. Okay, I'm pinging from router 9. I'm going to source that ping from our loopback 0, which is injected into OSPF. Okay, also working. And the reason it's working is because we have show IP OSPF. Okay, IP route OSPF. Okay, the reason it's working is because we have these inter-area routes or inter-area OSPF routes. Okay, so we're able to see routes coming from 1 network, 2 network, 3 network, 4 network, 5 networks, and the 7 network. Okay, the 4 network, whatever. Okay, then we have the 4 network. All right, so we're able to see everything. Okay, and even we have this default route. This quite interesting. Default route is been we have this default route where we didn't configure. Okay, so if I do ping, I ping 8.8.8.8. okay, it's working. Or if I ping even the 1.1.1.1. okay, so you might be wondering why I'm pinging 8.8.8.8 and 1.1.1. so if you see here, we have a router 1 and we also have a router 8. So what I did is that I made sure that the 8.8.8.8 is not assigned. Okay, we're going to see that when we come to router 8, you're going to see it's not assigned to the loopback interface of router 8, because I knew that that's the Google DNS. So I used a different interface here. I used the 8.1.1.8. okay, and this instead of 8.8. So when I ping this 8.8.8.8, I'm actually pinging the internet. Same way if I ping 1.1.1.1, actually pinging the internet, because the loopback interface here, I put 1.8.8.8. You might not be able to see it very well, but yeah, it's 1.8.8.8. So that's the loopback interface that I use here for. That was just to avoid conflict with some IPs that I'm going to repeat that I had to reduce troubleshooting in the internet. Okay. So now from router 9 we have full connectivity through area 0, area 1 to area 0. So now what we're going to do, we're going to configure area. We're going to inject these networks of area 2 into OSPF area 2. Okay. And then after that, we're going to do the other ones that are for the autonomous system boundary. That's beyond the networks that are beyond the ASBR. Okay, this is the ASBR, which is autonomous system boundary router. Okay, so this is the ABR, which means it's basically a router that separates different areas in OSPF. This is a router that separates different areas in OSPF. But this other router, router 4, separates OSPF area from a non-OSPF area like EIGRP. That's autonomous system boundary router, ASBR. Okay. All right. So we're going to configure right now area 2. So for router 5, right here, we're going to inject loopback 1 into OSPF area 1, and also the direct connecting interface between R5 and R6. Okay, it. And it's gonna bring up router 5. Okay, router 5. First thing you want to do is show IP interface brief, just to see what are the interfaces that are up. right, so this interface we want to put in area 2, and also this interface we put in area 2. Okay, 5, 6. Okay, so let's get to it. Click on terminal, router OSPF process 1. Okay, then we'll put the network. Network is going to be 105.0.4.0. Okay. Okay, put it in area 2. It's going to be area 2. And now we're going to do the same thing, but it's going to be for network. Okay, network 192.168.56.0. Okay. By the way, I need to. Oh yeah, that's correct. So area 0. Okay. Wildcard is clear. I just wanted to be sure that the wildcard is correct. Yeah, so that's it for area 5. For area 2 of router 5. I'm going to go out of there, save. I'm going to go to router 6 now. So router 6 is this one, okay? So the first thing, we can already see the interfaces here, 56.6 and the 6. Okay, so I'm going to put these two interfaces in area 2, okay? Terminal, router OSPF process 1. Okay, you can put the router ID. Router ID is 0.0.0.6. Okay. Okay, so 6, and we put the network. That was going to be 6.0.0.0 0.255, and it's going to be area 2. Okay, and the next one we want to add is the network 192.168.56.0, and it's going to be 0.0.0.255. Okay, area 2. We'll go out of there and we save. Let's check. Okay, let's check. See what we configure. Okay, so we put those two networks in area 2, and because of that, let's see if we have OSPF neighbor relationship with the R5. So IP press neighbor. Okay, so we have a neighbor relationship with the router 5. And by the way, there are other commands that you could also use for OSPF. Okay, so instead of you could also check the database link database net to say show IP OSPF database. Okay, let's see, question mark. Okay, you have topology, you have summary. Let's say this is summary. Okay. Okay. From here you can actually pull out more information about how the OSPF is built, okay, the different networks, database. Okay. All right, so let's test connectivity from R6 to the loopback interface of R5 that is participating in area 0. In that one first, let me just do show IP route OSPF. Okay, and I include 105.0. Okay, so that network is there, so we can ping it. Let's ping 105.0.4.5. Okay, sourcing from that loopback 0. Okay, that ping is there. Now let's do show IP route. Okay, OSPF. So we'll see all the routes that are present. Okay, so we can see the OSPF inter-area routes. They are all present. So now we should be able to see a more complete routing table. Okay, for all areas that are running OSPF. Okay, we have area that we have this one network from router 1, 2 network from router 2, 3 network from router 3, 4 network from router, so we have a full mesh, for all routers that are participating in OSPF. Okay, the only routers we don't have their networks here are the ones that are exclusively not running OSPF. Okay, for example, router 8, we don't have anything for router 8 here. We don't have anything for router 10. Okay, so right now what we're going to do is we're going to make sure that we put router 10 and router 8. Okay, well, we're going to configure RIP on router 9 and 10, also ERGRP on router 4 and router 8. So that's what we're going to do right now. And before doing that, we just maybe do a ping. Let's do a ping. So, show IP route. Okay. So since we see this default route, of course we can do a full ping from router 6 right to the internet. Okay. Ping 1.1. Okay. Just ping right to the internet. Of course, if you want to ping the URL, you have to enable the IP domain lookup. So if I want to ping the Cisco.com, that's not working, but of course for that one you need to enable the IP domain lookup on this router, and also define who is the DNS on the internet. Okay, I've shown that on many videos, so let's skip that one for now. What we're going to do right now, we're just going to enable ERGRP and then RIP. Okay, we can start with ERGRP first. Okay, let's start with ERGRP. Okay, so we're going to go to router 4. We're going to go to router 4 and we're going to say, first thing we want to do is a show IP interface brief. We're going to see all the interfaces that are available, and we see that the 4.4.4 is actually was injected into OSPF area 0. So this is the interface that has to be in ERGRP, okay, according to our definition. And also this interface has to be in ERGRP, okay. So let me go right there and just configure right now. Configure terminal. Router ERGRP autonomous system 50. Okay, let's call it 50. We'll say no auto summary. If we don't say no auto summary, ERGRP is going to by default summarize classical networks. Okay, so no auto summary, and then we advertise the network. What network are we going to advertise? The first one is going to be 104.0.4.0. okay, and so we advertise, we give the wildcard mask, which is 0.0.0.355. okay, so this is ERGRP. So okay, so it's going to be enter. So now we add another network into ERGRP. It's going to be network which is the directly connected interface, which is 192.168.48.0. okay, so this is a classical network. We don't need to specify the wildcard mask. Okay, it's going to understand it automatically. So we go out of there to show run section router. Okay, let's just see what we did. So we have OSPF network, we also have ERGRP. Okay, so we have these two networks have been advertised into ERGRP. So we're going to save that and go to router 8. So on router 8, show IP interface brief. Always want to be sure, because sometimes you think you configure those interfaces, but you did. So as I was telling you before, I specifically did not want to configure 8.8.8.8 like I've done in the other routers. Let's look back on router 8, because that 8.8.8 is we are connected to the internet, so I don't want that IP to be used locally. Okay, that way it doesn't create some kind of confusion with when we're pinging the internet. Okay, so the loopback here is 8.1.1.1. Okay, so this two networks, we're going to have to put them in ERGRP. So configure terminal router ERGRP 50, no auto summary. Okay, and so now we're going to advertise the network. What networks we're going to advertise? The 8.1.1. Sorry, 8.1.1.0. Okay, 0.0.0.3.5. Okay. Now also advertise the directly connected is 192.168.48.0. Okay, the classful network, so we don't need to advertise with the wildcard mask. So we can see there's ERGRP just came up right there. Let's go out there and just save it for now. Now we'll do show IP route ERGRP just to see if we have a neighbor. Show IP route ERGRP. Okay. Yeah, so we can see ERGRP route. Okay, right there, the D. D stands for ERGRP route. Okay, so we see it. So let's try to ping that ERGRP network that is on router 4. Okay, we're gonna ping 104.0.4.4. Okay, starting from loopback 0. Okay, that ping is working. Let's do show IP route, just general. Okay, show IP route. Let's see what we can see there. All right. So we can see that the only thing we can see right now is the ERGRP route, because ERGRP and OSPF, they're not yet communicating, they're not sharing routes, and that's what we're going to do in the next video. Not this video. Okay, this video, all we want to do is to make sure that ERGRP is enabled here, and OSPF area 1 and 2 are enabled, and RIP also, we're going to do RIP. We're going to enable RIP on router 9 and 10 for this. So let's I think we did the ping already. Yeah, we did the ping already. So ERGRP is working. Okay, but still we cannot see any route. We cannot go to internet. Okay, we cannot do anything from here apart from just see the directly connected the ERGRP route from router 4. So right now we're going to enable RIP on router 9 and router 10. Okay, let's go to router 9. I don't know if I saved the configuration for save, but I just want to. Okay, let's go to router 9. So on router 9, we'll do show IP interface brief. Okay, on router 9, we have this interface that we want to inject into RIP, and we also have this interface that we want to put into RIP. Okay, this interface and this other. Okay. So what we're going to do is going to do configure terminal. Okay, router RIP. Okay, so it's important to specify the version 2. Version 1 is RIP is obsolete. So also going to do no auto summary. Okay, RIP here. And then we specify the network that we want to inject into RIP. The first network we want to inject is the 109.0.4. Okay. .40. Okay. And let's see what's up. Okay. What they do. Network 09. 0.40. Okay, question mark. All right, this enter. Okay. Now the next network you want to advertise is the 192.168.90.0. So we're going to say network 192.168.90.0. Okay. So for RIP2, we don't need to specify even if I do this, it doesn't give you any option, but it's going to understand that it's a /24 network. All right. So go out of there and save. So now let's go to route 10. And before we go to route 10, show run session router, just to see what we did. Okay, so we have OSPF and RIP running on this router 9. So for RIP, we have these two networks advertised. Okay, so let's go to router 10 and do exactly the same thing. For router 10, we already see the interfaces here. So all we need to do is go to configure terminal, router RIP. Okay. Version 2, say no auto summary. Okay, and then we'll advertise the 10 network. 10, okay, 10.0. Okay, and we also advertise the 192.168.90.0. Okay, and we go out of there, we save. So the first thing we want to do on router 10 is to see if we have RIP routes coming up. Okay, we have RIP route. So we're going to do show IP route RIP. Okay, will we see anything? Let me make it on this one. Let me even reduce this one. Reduce this one. Expand this other one. All right. So what do we see? Okay. So we see a RIP route there. Okay. So what that means is we can actually reach the 9 network. Our RIP route is working. But of course, we cannot be able to see OSPF routes. Okay. So if I do ping, ping 109.0.4, okay, .9, and I source from our loopback 0, okay, the ping should work. In the same way, if I go to router 9, I do ping and I show IP route RIP, okay. What are the RIP routes have, so we can get to the 10 network, 10.10.10.10. If I do a ping to 10.10.10.10, okay, I'm going to source from loopback 1. Okay, we advertise loopback 1 into RIP, so if I source from loopback 1, it should work. If I do the same thing sourcing from loopback 0, which we did not advertise into RIP, that ping should fail. Okay, so yeah, so everything is good. So what that means is that we have our whole setup is working, okay, except that the RIP routes cannot see OSPF routes. The same way here, we cannot have ERGRP seeing the ERGRP routes are not redistributed into OSPF or vice versa. So that's going to be the subject of our next and probably the final video. Oh, I'm going to stop here because we need to, that's going to be a little bit more, going to see a lot of things together, how we can redistribute RIP into OSPF and vice versa, or ERGRP into OSPF and vice versa. Okay, so that's going to be the subject of our next video. Thanks so much for watching, and I'll talk to you in the next video.